Okay, let's get started. So today I'm going to talk about databases. So what's a database? A database is, if you're just, I guess we need to start with the definition, is a way of storing data so we can quickly get to the data that we want to find. And the most common database management uh, paradigm we have today is kind of the SQL database. I mean, there's a lot of NoSQL stuff, but I used to actually work for a company selling a NoSQL database. But at the end of the day, I mean, a lot of stuff is still pretty much SQL based. Um, okay, we'll stay there. Okay, so let's start with an SQL database that will get you going. And if you've never used SQL, is a pretty easy way to get started. Normally, an SQL database requires you to install something like Postgres or MySQL. Excuse me, but that isn't necessary in this case. We'll be using one called SQLite. Now I have installed already the command line tools for SQLite on my machine, but you can do so. It is available at uh, Matin SQLite 3. Uh, Basically, if you just Google Golang SQLite 3 or SQLite 3, you will come to this page. And or if you just Google SQLite 3, you will get to some packages or something for your system. In my case, I use a Mac, so I used Homebrew. So let's go ahead and add the SQLite 3 dependency to our application. So I'm just going to go and do a go get github.com mat and go. Okay. And that's going to add the dependency to our project. And if you need documentation on Go SQLite 3, it is available in the regular Go documentation site. Okay, and we're still installing. Usually this takes just a second. But while it's doing there, let's go ahead and get started with this. So I installed the command line tools, and for SQLite, um, you basically can use anything as your data store. So CD volumes. So we're going to create a database here, and we're just going to say SQLite 3, and we're going to name the database cars.db. Okay. Um, so one of the reasons I'm using SQLite 3 is there's no authentication, there's no setup. We can just basically get going. If you do want to use a more featureful database like PostgreSQL, there are lots of options for you, including using it from a Docker container or using a service like Azure to run the database for you. Um, you can definitely, you don't even have to run it on the same computer, the same type of computer. If you've got a Raspberry Pi, you can run it on there. But Sqlite has very, very little setup. Personally, I do prefer Postgres as kind of a full-featured database. So let's start with the basic kind of storage container for data in a SQL database, and that's the table. So we're going to go ahead and create table, and it's the law. You have to use all uppercase when you have SQL keywords. I'm joking, of course. You can use whatever case you want. SQL is case dependent. And we're going to give it an ID, which is the kind of the way we find a specific car in this database of cars. and we're going to make it an integer, and we're going to make it not null, meaning that if we tried to store a car without providing an ID, it's going to fail. And we're going to say it's a primary key. Okay, now we want more than just an ID for a car, right? So let's add a VIN. And in database parlance, that is going to be a var, meaning a variable length character string. And we'll set it to be 30 long. I don't know how long a VIN is on a car. If you're not familiar with a VIN, it's the long number that is on, if you look on the windshield of your car in the lower right-hand corner, you'll see a stamped metal piece with letters and numbers. That's the unique identifier for that make and model of car. What else do we want to store in a car? Color. And that'll be a var, I'll say 10. The reason we get to specify size is if you think about like a database for like a large company, and you've got, millions and millions of records, or even billions and millions of records, having a slightly smaller size to a field or something might help you better manage space. I don't know if that's as true nowadays as it was when I was learning about databases, but let's just stay with that fiction. And what else do we need? So we got the VIN, we got the color, and we got manufacturer. Let's see, that's var 20, and model is var 20. Okay. So now that I have my list of fields, I end it with a semicolon. I started it and ended create table with a semicolon here. And these are all the fields in my table. So I've got an ID, a VIN, a color, a manufacturer, a model. And if I go ahead and create the table, I get a syntax error. Great. Oh, I forgot to name the table. So create table cars. And I'm going to VIN, color, manufacturer. Oh, there we go. Okay. All right. So if I do a select star from cars, there's no data, right? So let's go ahead and insert some data. Again, it's the law. It has to be all uppercase. Insert into cars. And we're going to add an ID, a VIN, a color, a manufacturer, and a model. And we're going to say that is and the values we're going to give it are 1, and we're going to say a. By the way, strings in SQL are single quotes. So if you have errors and you have a string, check to make sure you're using single quotes. And the VIN is going to be ABC123. The color is red. The manufacturer is, say, Ford. And the model is Fiesta, because they make me happy. So now that we've inserted a row into our table, we can get back our row. Let's go ahead and insert 1 or 2 more. If I try to insert a car with the same ID, because it's the primary key, I'll get an error. So, model, and the values are going to be 2, DF123, and this is a blue Honda Civic. And insert into cars. And this is a gray. And let's make this Mercedes. And let's make it a C280. Okay, so now if we do select star from cars, we see our 3 rows. Okay, let's say for example we determined that the Mercedes was actually slate gray, or slate and not gray because it's fancy. So we can do an update cars set color equals slate where equals 3. Now if I do select star from cars, there. Okay. So those are the basic statements you'll use. Create table. If you need to delete the table, so let's say we create table useless ID primary. Let's say we don't want the useless table anymore. We can do a drop table useless. If we don't want, if we want to remove rows, we can do delete from cars where ID, sorry. All right. I'm trying to be very conspicuous by using uppercase for SQL keywords. Okay. Now that we understand the basics of kind of how we query data, insert some data, update data, and for a longer discussion of this, there are tons of resources on the internet that will help you learn SQL if you don't already know it. And if you are looking at becoming a developer and you think, oh, I'll just use files, or I'll just use a service or whatever. You should know SQL. It's kind of even if you don't intend to use it, it's kind of like a lingua franca for data. And you'll find a lot of tools, even if they aren't SQL databases, will give you an SQL interface because that's what people understand how to query. So let's go ahead and start by connecting to the database. So go run. All right, so let's go ahead and close this. And so we have our database file cars.db. So we are going to import 2 packages. First off is database SQL. All right, that is the Go API for database management, and you can go, the package is right here. This will allow us to connect to a database and send those SQL commands to the database from Go. The other package we need is a reference to the Sqlite package. Now, if you've noticed with Go, if you have a package that you aren't referencing, that's an error. And we're not going to reference the Sqlite package directly. We're going to use the Golang abstraction for all SQL databases. So we're going to use an underscore to say, I'm going to bring in this database dependency, but I'm not really going to use it, but I do need it to compile with the rest of my code. And so you want github.com, Matten, Go, SQL. Okay. Now, being very careful not to save, I will do db error open. And to open a database, I need to give it a driver name, Sqlite 3, and a connection string. In this case, the connection string is just going to be cars.db. Why do I have a red squiggly? There, just had an error. Anyway, okay. So we've got our database and possibly an error. If error not equals nil, log printf can't connect. And we're going to head and say query. So we're going to go ahead and use the SQL query to start with. And this function takes a string, which is the query string, and then possible arguments. So in this case, we're not passing any arguments, but normally they would be command line arguments that we would have in a query, and that is database specific in Go, and I forget off the top of my head what Sqlite uses. What does it use? Oh, okay. Let's not worry about that. But it returns rows and an error. So rows error. All right, so we've executed the query and we've gotten back possibly an error. So if error not equals nil, log.printf failed to query database. All right. And we are going to use the for loop for rows.next. So this will move to the first time we call this, it moves to the first result. And we need some sort of an object to store our cars in. So our cars are an ID, which is an integer. And then I believe it's just strings, right? So 1, 2, 3, 4 string. VIN color manufacturer model. So VIN color manufacturer model. Okay. And so let's see. Var result car. Nope, it's that way. Sorry if I'm doing a little bit of Java programming recently and I don't understand why. So we use a function called scan to take the result row. So again, when we ran a select, we got back a bunch of rows here. So we're going to go ahead and scan the data into our car, passing it the address of the various fields. E, manufacturer. I was going to try to tie this to a web request, but I don't think we're going to have time. So we're going to go ahead and just, let's add a, well, let's just do that. Let's just scan that. And that should give us some nicely formatted output. Not forget our new line. And okay. So let's go ahead and run this. There we go. So we got the data from our database into our Go program. Okay. And if we wanted to, we could abstract this into, a lot of times we use kind of a repository model, so we could have type car repository, and that'll be a struct. It'll be empty for now. Actually, let's put a SQL database reference in here. So we'll put a con okay in all cars and car under a slice of cars error. And we're just going to take the this, and we're going to go ahead and put it in here and replace that with con for database connection. And let's see. To a slice of cars. Whether it's squigglies. No, let's not do it that way. Okay, create an empty slice. And instead of printing it, let's move this to a member func. Let's create a stringer on here. And let's make this an sprintf. we go. Okay. So we scan the result and we add the result to our cars. All cars equals, I'm going to append it. So we take the slice type, all cars, and then our result. And then we return all cars. Okay. And we're just going to catch the error here because scan could return an error. So if there's a problem scanning the data into your variables, scan will throw an error. So let's go ahead and return nil error. And okay. And the other function we want, so we've got this all cars function. We want add car. And we're going to go ahead and call exec, which is another common function. So we're going to head and call crcon exec. We're going to say insert into cars, and it's id vin color manufacturer model values. I want to say $sign. I think it's just question mark, question mark, question mark. 1, 2, 3, 4, 5. You have to have as many question marks as you have fields here. So we're going to head and execute that, and we're going to pass, just like select could take a variable number of parameters, this could take a variable number of parameters as well. And let's go ahead and pass the fields in car. ID, VIN, color. Now, one of the things I am being careful about is the order in which I put things. So exec is going to return the result field in an error. We're not really interested in the result, but we are interested in the error. Yeah. No. Failed to insert car. Either way, return the error because it's either going to be nil or not nil. Okay. So let's go ahead and create a car repository. And we're going to go ahead and get a connection from the database. Oh, that could return an error. I'm sorry. So go ahead and create an empty car repository. Now, coming up on time here, and I want to get this done. Cr dot equals. So we're going to get a connection to the database. We didn't do this before, but we can return a fresh connection, and it's tied to a context. Now, in this case, the context would allow us to do things like cancel like time out the transactions or whatever, but in this case, we're going to go ahead and create just a context background since we're not going to time it out or anything. Whether it's squiggly. Oh, whether it's squiggly. Cannot use DB. Oh, okay. All right. So this needs to be an SQL con. Oh, I'm doing it wrong. This needs to be an SQL DB. And we're not going to use con. We're just going to take the con. Okay. All right. Going a little bit over, but go ahead and print out all the cars. Panic on the error just to be quick about it. And let's go ahead and run this. Oh, we have an extra new line back in here we don't need. Go ahead and run this. Okay. Now let's go ahead and before that, we are going to go ahead and CR add car, and we're going to add a new car. And let's create a car. Sorry, too much time with Java, and I don't know why. And Vin. Let's see, what do we want? Vin, color, blue, manufacturer. Let's make this Volvo. And model V60. I think that's a Volvo. All right, so let's do an add car and then call all cars. So let's run it this time. And there's our new car. And if we go to the terminal, and if we go ahead and connect to our database there, select star from cars, we see there's our Volvo. All right, I ran over today, sorry about that. But I did want to cover, the basics of getting started. I kind of ran through some of this stuff pretty quickly. But again, there are so many resources out there for learning SQL. I highly encourage you to go look at some of them. I just wanted to show you this to get you started, to give you a point where you could kind of just say, okay, this is kind of the pattern I'm looking for. This is what the code kind of looks like, and just to get you a feel for it. Anyway, I think Thursday I'm going to cover Go routines, but that's it for today. Thanks, and sorry about running late.